Greetings! What you're looking at is my Asteroids clone. Asteroids was one of the last independent projects I did before getting a job in software development. I really enjoyed the project, and I've used it to train new developers for years. Asteroids is also the project I return to when I want to experiment with new things. Recently, I decided to add allies to shoot for me. For now, I'm calling my allies satellites. The first and easiest thing to do is have the new satellites shoot stationary targets. This requires that the satellite have a target, the angle to the target, and the precision necessary to hit the target. Here, I added a satellite and an asteroid to the game. The first thing to do is have the satellite target the asteroid. I did this by identifying the nearest asteroid. Fancier targeting can come later. Next, I added a gun to the satellite. Internally, this is just an angle I called gun direction. The satellite figures out which way to turn the gun by subtracting the current gun direction from the angle to the satellite. The result needs to be unwrapped, so it is between negative pi and pi. I limited the gun turn rate to 1 radian per second for now. The last consideration is precision. How far off can the gun direction be before the satellite is allowed to shoot? I internally set this to 0.1 radian, just so I could watch the satellite shoot. A calculated value would be better, so our gun doesn't need to turn unnecessarily. I placed a satellite, target, and bullet on this chart. The maximum angular offset that will allow a hit is when the bullet path is tangent to the target. Recall your trigonometry. Here, we have a right triangle with the hypotenuse, adjacent, and opposite arms labeled. Given the length of the hypotenuse and the opposite, we can find the angle with arcsine, shown here. Overlaying the objects, we can see the hypotenuse is the distance from the satellite to the target, and the opposite is the sum of the radius of the target and the bullet. I want to visually show that our precision equation is correct before I write any code. To do this, I will use the graphing calculator on Desmos.com. Desmos has a free set of math tools I use to test my ideas. Under initial conditions, we only need 4 things: the position of the target, the position of the satellite, the radius of the target, and the radius of the bullet. Under calculations, I define P as the relative position between the satellite and target. The distance d is the magnitude of P. Desmos doesn't seem to have a convenient tool for the magnitude, so the Pythagorean theorem will work just fine. As we discussed, our angular precision is the arcsine of O over h, where O is the sum of the radii of the target and the bullet, and h is the hypotenuse. Then we will need the angle to the target. This is the arctan of py over px. Finally, we need the distance to the tangent point. This is d times the cosine of the angular precision. In the Tools section, I'm going to add a couple tools to make writing circles and lines faster. The first draws a circle. The second is a function called line, which returns a unit vector. Under Display, I start by properly representing our target by adding a target radius circle around it. I then calculate the tangent points at the edges of our cone of precision. I did this by starting at the satellite position and extending a unit vector along the tangent line. Here, I added a couple bullet radius circles around our tangent points. To finish up the graph, I drew lines from the satellite to the target and bullets. This will clearly show where shooting will result in a hit. Now that we're finished, we can play with the chart. This allows you to double check that you didn't forget any angles. This has the added benefit of showing that I need a new laptop. With a working proof of concept, I made the same plot in the game. I then modified the precision requirement to match the new calculation. You can see that the gun fires as soon as it enters the firing cone. That means it's time to try it out against normal asteroids. For normal asteroids, I halved their radius to allow for the jagged edges. In the next video, I will discuss the math for hitting moving asteroids from a moving satellite. For those of you who made it this far, thank you for watching. This is my first video of any kind since a German class assignment in high school. This is a brand new channel, and I'm looking forward to hearing how you like it.